Sorry, Christina. Christina, we don't listen to you. There is no voice.
Is it better now?
Now we can hear you. Yeah, thank you.
Thank you for notifying me. I'm sorry you couldn't hear me. So I will just shortly go back maybe to this page where you get the explanation of how to use the control panel. Control panel is an important thing because you can post your questions in the text field below. And I ask all attendees to post their questions in written form in this field. You have the possibility to talk too, but the feedback and background noises are often very disturbing, so I ask all attendees to mute their micros and post their questions in written form. There's also the symbol for raising your hand, so if you want to draw your attention to you, please click this icon and I will get back to you in a written chat. All micros are muted for attendees and the session will be recorded. You can get back to it via the Foodstar network, via the Foodstar project website. So this is now my short introduction of the Foodstar Training Alliance. It started in January 2015, and we want to bring together universities and food industry who have different approaches on knowledge, and the closing the gap shall be facilitated by the Foodstar activities, by the Foodstar network. We try to establish long-term partnerships on a European level and want to have a low threshold offer so we can involve as many stakeholders as possible. Foodstar partners are coming from all over Europe. There are 7 universities, 3 food companies, and 11 multiplying institutes. These are the universities involved, with BOKU being the coordinating institute. The food companies come from Portugal, Spain, and Switzerland and are Frulact, GB Foods, and Nestle. The multipliers are also from all over Europe. LVA is one of them, and the networks of university teachers, industry, and students are also involved and are associated to your Foodstar activities. Foodstar is not only a virtual project, but we are also maintaining physical hubs. These are the locations of those physical hubs where you can refer to. So thank you for notifying me that I was muted. I asked you to send your suggestions for further topics for the Foodstar program because we are still developing lectures. Please send your suggestions to office@iseki-food.net. So it's now time to introduce to you our today's lecturer. It's Nuno Ribeiro. He is coming from the Polytechnic Institute of Coimbra in Portugal, and he's an environmental engineer and is occupied with quality management systems and auditing them. So this is also the contents of our today's webinar. It's all about the standard used to certify the procedures analyzing institutes have to follow for doing certified analysis. And I will take 1 minute to hand over the screen to Mr. Ribeiro. I see you're already ready. So you should get the notification to take over the screen. Are you ready to take over the screen?
Good afternoon and welcome to this webinar about yes, can you hear me?
Yes,
can you hear
we can
me?
hear you perfectly well. Yes, and we can see your screen. You can already start the presentation.
Then if there is any problem, you may.
I will notify you. So ready to start.
Oh, okay, I'm listening to you with some difficulty, so I don't know if it's my internet. So I will start.
Okay, start, please. Thank you.
Welcome to EN ISO IEC 17025 standard webinar. In this webinar, I will start with a little introduction about quality management and a history and benefits of accreditation. We'll enter into. So how can we define? First of all, according to ISO 9000, quality is a totality of features and characteristics of a product or service by stated or implied needs. So and stated of the customer.
Nuno, the audio is not working perfectly.
The management system, it's a set of interrelated.
Nuno, we can't hear you. We can't hear you. Super.
Christina, can you hear me?
Yes, I can hear you now.
Maybe one option what we could try is that he sends the presentation and you display it and he doesn't share his screen.
Mm-hmm. But I'm afraid there is an audio going with the presentation and I don't know how to handle it. I know that there were some problems in the technical check because the audio had to be changed on the PC of Nuno from microphone to stereo mix, and I'm not sure if this worked this time.
Okay.
Thank you, Gerhard, for for your support.
Notified by a colleague she's listening to the webinar.
As I was not aware that my mic didn't work.
Yeah, last time I didn't show my screen.
So it's always something new here. We can't do enough webinars.
But that's life.
That's life, you said.
So, but maybe you can try that. You think it's only the microphone, his microphone is the problem, not the pen?
I think that there's a recorded audio to the presentation, and it has not to be transmitted via the microphone, but via the other audio system of the PC.
Oh.
And so this is the problem, because microphone worked perfectly well, but the transmission of the audio that is recorded with the presentation is not easily transmitted, as it seems, because it needs a lot of space, a lot of resources of the internet linking, and this is just the hard thing. He tries to. Maybe I get it now. Yes. I think he's sending it. Looks like it. So I will show. Yes, maybe this is the solution. I have to apologize to all our attendees. I'm very sorry for this inconvenience. This was not foreseen. So dear attendees, I have a notification from Nuno. He tries to send me the presentation by WeTransfer. I have not received it until now. Nuno, you should be able to talk. We should be able to hear you. Please keep in mind that you have to change your audio settings from stereo mix to microphone.
Can you hear me?
Yes, we can hear you now.
Oh, sorry. Okay, sorry about this situation. I don't know if it's my internet. So anyway, I just sent it. I just sent the presentation to you, Christine, by WeTransfer. And maybe it's better to if you transmit it. I also want to apologize to attendees.
Did it work during the technical check by the
Yes,
ceramics?
yes, it worked, and just before with Gerard, he was listening.
Okay.
Do you have it already?
No, it takes some time to download. I
Yes.
have it's another 30 seconds, it indicates here. What is the duration of the presentation as a whole?
About 60 minutes. 55, 60 minutes. 60.
Uh-huh. So it's still downloading, but it's arriving. Well, it takes its time. It's quite a big file.
If you want me to try again, from my side.
Yes, maybe this would be a possibility. I have another 5 seconds here for the download to be finished, but I think I can then try again.
So I will try it and feedback me if it's all right, or if we can try other way, okay?
I hope the audio is working from my side, because this is the only weak point. It really takes very long to open and to download. I'm just waiting for.
But do you want me to try my presentation from here?
As I would rather, yes.
So I will try. Welcome to EN ISO IEC 17025 standard webinar. In this webinar, I will start with a little introduction about quality management and the brief history and benefits of accreditation. Then we will enter into ISO 2025 and its requirements. So how can we define quality management system? First of all, according to ISO 9000, quality is a totality of features and characteristics of a product or service that bear on its ability to satisfy stated or implied needs. So good quality is defined as meeting or exceeding the expectation and the requirements, both stated or unstated, of the customer. A management system, it's a set of interrelated or interacting elements to establish policy and objectives and to achieve those objectives. So summarizing, quality management system is a management system to direct and control an organization with regard to quality. A quality management system under ISO 9000 serves many purposes, including improving processes, reducing waste, lowering costs, and setting organization-wide direction. Now, what are ISO standards? From where it comes? International Standard Organization is an independent international organization with membership of 162 national standard bodies. And the standard, this organization publishes standards, and the standard, it's a document that provides rules, guidelines, or characteristics for activities or for their results, aiming at achieving the optimum degree of order in a given context. They can take many forms apart from product standards. Other examples include testing methods, codes of practice, guideline standards, and management system standards. Just to see some milestones of certification and accreditation. In 1946, after World War II, there was the foundation of International Standards Organization. In 1951, the ISO publishes the first standard, the ISO R1. The standard was the standard reference temperature for industrial length measurements. In 1960, ISO publishes the standard ISO 31 on quantities and units. In 1987, started with the quality management standard with the ISO 9000 family. In 1996 were born ISO 14000 family and on environmental management standards. In 2000, the ISO 1725, the objective of this webinar, was published. And in 2005, the ISO 22000 family on food safety management standard were published. So, where can we see quality in food safety? Here are some concepts and documents that you may know already and that are related and contributing matter of food in the matter of food safety. First of all, the Codex Alimentarius. In 1963, the WHO, World Health Organization, and the FAO, Food and Agriculture Organization, published the Codex Alimentarius. This is a compilation of international food standards, guidelines and codes of practice, contribute to the safety, quality, and fairness of this international food trade. In Codex, among with others, lies the concept of HACCP, hazard analysis and critical control points. This is a systematic preventing approach to food safety from biological, chemical, or physical hazards in production process. So HACCP and some quality management requirements from ISO 9001 are included in the text of ISO 22000, that is the international standard that specifies the requirements for a food safety management system. On the other hand, we have ISO 17025 that establishes the general requirements for the competence of testing and calibration laboratories. The application of these standards in food laboratories includes some of Codex guidelines. When we talk about ISO 9001, we are talking about certification. However, with 17025, we talk about accreditation. So what is the difference? Certification is a recognition of an effective quality management system meeting the requirements of ISO 9000 series. On the other hand, accreditation is a recognition of the technical competence of an organization to properly perform specific types of testing. Accreditation is distinct from certification, which focuses on an organization's overall compliance with systems and product standards rather than technical competence. ISO 17025 focus on technical competence. Who gives recognition? The accreditation bodies. What is an accreditation body? ILAC is the international organization for accreditation bodies involved in the accreditation system. Then above this, we have regional accreditation bodies. We have three examples: Inter-American Accreditation Corporation, Asia-Pacific Laboratory Accreditation Corporation, and European Cooperation for Accreditation. These are specialist regional bodies that are associations of regional or national accreditation bodies. We have the European, as an example, the European Cooperation for Accreditation. This is an association with 36 full members and 13 associate members. Each country under international accreditation system has a national body, as you can see. We have seen what is accreditation. What does my laboratory gain being accredited? First of all, it provides confidence in results and the acceptance of the public and industry. It meets the buyer specification or regulations. It gives a national and international recognition and increased competitiveness and market share. It's a guarantee of good quality, good laboratory practice, and ensures better support in case of legal challenge. And ultimately, it saves money when a management system is where can we see the application of this standard in food industry? The scope of activity of food testing laboratories is applicable mainly in the following areas: food chemistry, microbiology, rheology and other physical testing, food toxicology, sensory testing, and molecular biology. Some general considerations of EN ISO IEC 17025. Every standard has its own code. So this is an international standard organization and International Electrotechnical Commission standard, because ISO has formed joint committees with the International Electrotechnical Commission to develop standards and terminology in the areas of electrical and electronic related technologies. 17025 is the identification number. The year of the version. All ISO standards are reviewed every 5 years to establish if a revision is required to keep it current and relevant for a marketplace. ISO 17025 is currently from 2005. It's currently being revised, and a new version is expected to be published in mid-later 2017. And then the EN, that means that this specific version is adopted in Europe. Then it can be used by countries. For instance, in Portugal, the translated standard is NP-EN ISO IEC 17025 from 2005. ISO, the first version of ISO IEC 17025 was published in the 2000 year. The first edition of this standard was produced as a result of extensive experience in the implementation of ISO IEC Guide 25 and EN 45001, both of which it replaced. This version contained all of the requirements that testing and calibration laboratories have to meet if they wish to demonstrate that they operate a management system, and to demonstrate that the laboratories were technically competent and able to generate technically valid results. In May 2005, there were changes made with the publication of the latest version of ISO IEC 17025, which mainly addressed the management requirements in order to reflect the principles of the ISO 9001 from 2000. So we have seen already that ISO 17025 incorporates both quality management and technical requirements. Where ISO 9001 is the overall standard for quality management systems, 17025 provides specific guidance on applications of the ISO 9001 to test and calibration laboratories. The ISO 9001 specifies quality system requirements on a laboratory's capacity to provide products to its clients, and ISO 17025 prescribes a combination of quality requirements and also its technical competence to provide such services. This specific standard is divided in 5 sections. the scope, normative references, terms and definitions, and management requirements and technical requirements. These two sections will be analyzed in this webinar. Then we have two annexes, Annex A with cross references to ISO 9001, and Annex B with guidelines for specific fields. So from now we will focus in management and technical requirements in order to design a quality management system under ISO 17025. The ISO 17025 has 15 management requirements that constitute 15 sub-chapters of the section 4 of the standard. So we will start analyzing each requirement following the standard section 4. First of all, what is a laboratory? Laboratory may be a laboratory with its own legal personality, composed of one or more technical units, or it may be a laboratory integrated in an entity with its own legal personality. The laboratory shall show that it meets the regulatory requirements applicable to its accredited area of activity and or to accredit. Every time that the verb shall appears, it's a mandatory requirement. Where it is should, it's a requirement, an optional requirement in this standard. So these regulatory requirements applicable may be applicable to conducting testings or calibrations or sampling. But the evaluation of compliance with other legal requirements such as contributory obligations or with social security does not fall within the scope of ISO IEC 17025. The ISO 17025 does not assess the legal requirements. The quality management system shall be designed to cover all activities for which the laboratory is seeking accreditation, regardless of the location. Work carried out in the laboratory's permanent facilities, at sites away from its permanent facilities, or in associated temporary or mobile facilities shall be identified. Sampling has to be inclined, maybe in some service, sampling has to be in client facilities, but the analysis is performed always in the lab. If the laboratory is part of an organization performing activities other than testing, the responsibilities of key personnel in the organization that have an involvement or influence on the testing activities shall be defined in order to identify potential conflicts of interest. Written arrangements should be in place to manage pressures and ensure that there is no undue pressure on laboratory staff. Many laboratories are establishing a conflict of interest form that is signed by the employee on the first day of employment. There also should be a policy statement in the quality manual and procedures to protect the client's property, information and rights. The laboratory shall have an organization chart where must be identified the insertion of the laboratory into the structure of the entity, the internal organization of the laboratory, identifying, for example, sectors or technical units and their officials, posts or posts, and hierarchical relations. The integration of the bodies responsible for the quality function into the structure of laboratory and any entity in which it may be integrated. Also, all personnel who manage, perform or verify work shall have their responsibilities and authorities documented. ISO 17025 defines two key posts. The technical management, that there is not necessarily one technical laboratory manager, but the laboratorial management structure must be defined. And the quality manager. The laboratory shall appoint a member of staff as quality manager. The roles and responsibilities of these two key posts must include the responsibility for ensuring compliance with these international standards and shall be defined in the quality manual. The quality manager is the only post required to be defined by ISO 17025. You do not have to use the actual title, but you must identify the person responsible for these functions. This quality manager, or whatever you call, is responsible for implementing and operating the quality system on a day-to-day basis. It must be internal and full-time employee. For all of these key posts, the laboratory should define deputies, especially those of quality manager and laboratory manager, so that their functions can still be discharged in their absence. Individuals may have more than one function. It may be impractical to appoint deputies for every function, and institutions shall have a qualification appropriate to duties to be performed. So a common scenario is for the laboratory manager and quality manager to deputize for each other, where the quality manager has appropriate technical expertise. But you can make whatever arrangements are suitable for your particular situation. Communication. Top management shall ensure that appropriate communication are established within the laboratory, and that communication takes place regarding the effectiveness of the management system. Communication in the laboratory can occur in many ways, for example, through memos, telephone, mail, or meetings. But it's recommended that the laboratory privilege registers forms of communication. To what concerns to management system requirements, we have the documental structure. It is a good idea to describe the laboratory's documentation and hierarchy in the quality manual. This usually consists of a documentation pyramid, just like this, with the quality manual at the top, then operating procedures and working instructions. The documentation has two main roles. It is a mechanism for defining the quality system so that there is a consistent and secure basis for monitoring the system, and it is a means of communication within the laboratory so that all staff know their responsibilities and the procedures to be followed. So what the laboratory must document? The laboratory shall document policies, systems, programs, procedures, and instructions. These to ensure the quality of the test or calibration results. Also, all documents shall be written in an accessible language and understood by the user, and needs to demonstrate compliance with the requirements of ISO 17025. Which brings us to the quality manual. The quality manual is the key piece of quality documentation, and this is where the laboratory describes the management quality system structure, quality policy, quality objectives, and supporting procedures. The procedures doesn't have to be completely described in a quality manual, but they must be referred there. And what concerns to quality objectives, they must be measurables. The quality policy statement is defined in quality manual and must include the laboratory management's commitment to good professional practice and to the quality of its testing or calibration in servicing its customers, the management statement of the laboratory standard of service, the purpose of the management system related to quality, a requirement that all personnel concerned with testing and calibration activities within the laboratory familiarize themselves with the quality documentation and implement the policies and procedures in their work, and the laboratory management's commitment to comply with this international standard and to continually improve the effectiveness of the management system. So talking about the supporting procedures, must allow that these procedures, or all procedures, must allow that anyone can do the job. It means that a person reading the procedure can perform the test or the calibration. It is not essential for the laboratory to write up all methods and operating procedures. For instance, where standard methods are used, the requirement for a method's description can be met by making available to staff a copy of the standard specification, for example, a national or international standard. Similarly, equipment or operating instructions may be made available entirely in the form of manufacturer's manual, if these provide all of the information necessary. So we have these three supporting procedures: management or quality procedures, technical procedures, and work instructions. So the supporting procedures must be clear and ambiguous, must have clear and ambiguous identification of the document, evidence of their validation and updating, the purpose and scope of the activity described in the procedure, must contain the who, does, the what, and that is the action, how, that is the procedure, and when, the conditions. Applicable materials, equipment, and documentation, and activity control in the recording mode. Every time we can do the procedures as a fluxogram, it is better, because the fluxograms are simple to read and to perform the test, it makes it easier. Top management shall provide evidence of commitment to the development and implementation of the management system, and to continually improving this effectiveness. Top management commitment to continual improvement of the management system can be shown by active participation in development and revisions to the quality manual, the active participation in the treatment of complaints, preventive and corrective actions, and used to make any improvements to the system. The top management shall also communicate to the organization the importance of meeting customer requirements, and ensure that the integrity of the management system is maintained when changes to the management system are planned and implemented. After, we will see how these changes are made. In document control, the laboratory shall establish and maintain procedures to control all documents that form part of its management system, internally generated or from external sources such as regulations, standards, or other normative documents, methods, drawings, software specifications, every document that may be on various media, whether hard copy or electronic, and they may be digital, analog, photographic, or written. In food labs, laboratories should monitor the codex as a source of international accepted standard methods, and also any requirements of their national and other regulatory authorities. This is to ensure the documents and methods they are using continue to be suitable and are in compliance with applicable requirements. Document approval and issue. All documents issued to personnel in the laboratory as part of the management system shall be reviewed and approved for use by authorized personnel prior to issue. A master list or an equivalent document control procedure identifying the documents in the management system shall be established and shall be readily available to avoid the use of invalid or obsolete documents. This master list can be an index of the documents and should indicate the current revision of all documents. All controlled documents should have a list of who gets the document in order to prevent unintentional use of again, obsolete documents. So it must have identification. Every management system documents shall be uniquely identified. Such identification shall include the date of issue and or the revision, identification, page numbering, the total number of pages, or a mark to signify the end of the document in the issuing authorities. The simplest way to show evidence of approval is with a signature on the documents. It's also possible to set up an electronic approval for documents. These documents are periodically reviewed and, where necessary, revised to ensure continuing suitable and compliance with the applicable requirements. And invalid or obsolete documents are promptly removed from all points of issue or use, or otherwise assured against unintended use. Obsolete documents retained for either legal or knowledge preservation purpose are suitable marked like this. Changes to documents shall be reviewed and approved by the same function that performed the original review, unless specifically designated otherwise. The altered or the new text shall be identified in the document or the appropriate attachments. The removed text may be struck out, and the new one can be highlighted. Whenever a client requests a service, there should be procedures ensuring that the requirements, including the methods to be used, are defined, documented, and understood. The laboratory has the capability and resources to meet requirements, and the appropriate test method is selected and is capable of meeting the customer's requirements. Records of reviews, including any significant changes, shall be maintained. These records shall also be maintained of pertinent discussions with customer relating to the customer's requirements or the results of the working during the period of execution of the contract. The customer shall be informed of any deviation from the contract. And if a contract needs to be amended after work, the same contract review process shall be repeated, and any amendments shall be communicated to all affected persons. Subcontracting and of tests and calibrations. It is possible that the laboratory isn't able to perform a specific test or trial and needs to subcontract other laboratory to fulfill the customer's request. But it shall, the laboratory shall subcontract an accredited laboratory. The purpose of this is to guarantee the compliance of 7025. If a laboratory chooses to approve an unaccredited subcontractor laboratory, it should be done using an audit process similar to your own internal audit system, which assures the compliance with the requirements of ISO 7025. And then the customer always must be informed, in preference in writing, and accept the conditions. The laboratory is responsible to the customer for the subcontractor's work, except in the case where the customer or regulatory authority specifies which subcontractor is to be used. And also the laboratory shall maintain a register of all subcontractors that it uses for tests and record of the evidence of compliance with the international standard for work in question. When purchasing service and supplies, and subcontracting is included here, the laboratory should have a policy and procedures for the selection and purchasing this service and these supplies. Relevant supplies are all consumable, standard, certified reference material, measuring and reagents and service like subcontracting, calibration, maintenance, training, and audits. At the end of the purchase, suppliers must be evaluated and included or not in a list of approved suppliers. So all of these supplies or this service must be inspected and approved before their use. The laboratory must provide to customer all of the information that the client needs, and must provide access to relevant areas of the laboratory for the witnessing of the tests. This permission to follow up the tests by the client should take into account the operational and the environmental conditions necessary to avoid invalidating the results, the conditions of confidentiality in relation to the work of other clients, and possible safety conditions. Then laboratory must have customers' feedback, which can be customer satisfaction surveys or review of test results with the client. In this, customers' feedback can be included in complaints. The laboratory shall have a policy and procedure for the resolution of complaints received from customers or other parties. Excuse me. These and the next requirements are related with the requirement 411 and can all be included in a single procedure, as we will see. The laboratory must have a procedure for control of non-conforming testing or calibration work. A non-conforming work may be defined as a test or a trial which is not performed in conformance with the rules of the lab. So it all starts with looking for the origin of non-conformity. A non-conforming work can result from customer complaints, quality control, instrument calibration, staff observations, test reports, whatever. And then we have to establish management responsibilities, identify the significance evaluation, perform an immediate correction, then notificate the client and resumption of the work. In this requirement, it is important to see the difference between correction and corrective action. A correction is, for instance, a test repetition. It's in short time. A corrective action is always in long time in order to avoid the possible errors. So there may be training, supervision, or disqualification of the operator, or the supplier, or the equipment. This takes special relevance in food laboratories since we are dealing with food safety issues. Rapid notification of non-conformity to customers or to regulators may necessarily prevent or reduce public public health incidents. The laboratory must continue to improve the effectiveness of the management system. This may be performed through the use of quality policies, quality objectives, internal audit results, data analysis, corrective and preventive actions, and management reviews. This is a PDCA cycle, which means plan, do, check, and act, and can be applied to quality management system. In periodic management reviews, quality objectives must be established based on measurable indicators, and the monitoring of these objectives allows to the system to be continuously tuned. And we pass to what I referred before, the correction action. A problem with the quality system or with technical operations of the laboratory may be identified through a variety of activities, such as the control of non-conforming work, internal audits, external audits, management reviews, and feedbacks from clients or staff observations. The procedure for corrective action shall start with an investigation to determine the root cause of the problem. Without this cause analysis, then the laboratory couldn't understand or cannot understand what truly caused the problem. And they will have difficulty finding the corrective actions necessary to prevent the recurrence of the same or similar problems. Then we must select and implement the corrective action, and then we need to monitor of correction action. There should be some evidence that a follow-up of the effectiveness of the corrective action has been performed. And then the laboratory must always record the result of evaluating the effectiveness of the corrective actions implemented. On the other hand, we have preventive action, where corrective action is a response to a finding of a non-conformance. A preventive action is occasion when circumstances are identified where a quality failure or non-conformance is a possibility, or when an opportunity is identified to strengthen the quality management system. In this respect, preventive action is a total quality management concept and contains elements of quality improvement. When it concerns control of records, the laboratory shall have procedures for identification, collection, indexing, access, filling, storage, maintenance, disposal, quality, and technical records. Records may be in any medium, such as hard copy or electronic medium, and the laboratory shall have procedures to protect and backup record stores electronically, and to prevent unauthorized access or amend of these records. The technical records shall include sufficient information to establish an audit trail. This trail should lead back to the original documentation that defines what work is requested. Then these records shall contain sufficient information to allow the repetition of the test in as close to the same manner as the original test. It must be possible to redo the test almost exactly as the first time. And these records shall be identified not only by the people who are currently working with them, but also with those who can possibly integrate in the future the laboratory and may also have to deal with these past reports, for instance. All laboratories must have a cycle of internal auditing, usually 1 year. An internal audit allows the laboratory to detect and correct deficiencies as well as to continuously improve the quality system. The laboratory is free to perform just one audit a year and complete it once and cover all of the requirements of the standard, or perform several audits on different areas and aspects of ISO IEC. But a cycle of auditing must be completed within a year, and all ISO requirements and technical areas must be audited in an internal cycle of audits. And then we have the management reviews. The laboratory's top management shall periodically conduct a review of the laboratory's management system and testing activities to ensure their continuing suitable and effectiveness, and also to introduce necessary changes or improvements. In management reviews, the inputs contains our audit reports, feedback from customers, audit and review program, quality control checks, non-conformities, complaints, preventive actions, and results from interlaboratorial trials. These inputs are analyzed and result in a new audit and review program, new quality objectives, preventive potential preventive actions, and interlaboratory trials program for the next year. And then just to summarize, these are the procedures that laboratories must have. Each laboratory can design procedures the way it fits better to daily job. So documents and records control, review of requests, tenders and contracts, purchasing service and supplies, customer satisfaction assessment, complaints, control of non-conforming work, corrective, preventive and improvement actions, and internal audits. Now we will analyze the technical requirements. Many factors determine the correctness and reliability of the tests performed by a laboratory. These factors include contributions from these technical requirements that are included in section 5. In what concerns to personnel, the laboratory must have or must provide the assurance of competence, have a personal training program, all personnel must be under contract, and laboratory shall have a document with job descriptions. For assurance of competence, the laboratory can define a minimum qualifications for job, and the demonstration of this competence can be achieved by periodically performing tests of performance, practical or theoretical, comparisons with more experienced and qualified personnel, and participation in laboratory comparisons. It is recommended that at least annually the competence of the personnel in carrying out the tests is demonstrated. In food laboratories, it keeps a special importance to food microbiology labs, where the interpretation of test results for identification and verification of microorganisms is strongly connected to experience of the performing analyst and should be monitored for each analyst on a regular basis. In the document with job descriptions, this document must contain the responsibilities. These responsibilities are such as performing tests or calibrations, planning of tests and evaluation of results, reporting opinions and interpretations, modification and development of new methods, expertise and experience required, qualifications and training programs, and managerial duties. When we pass to accommodation and environmental conditions, there are various types of facilities. A laboratory can have permanent installations, temporary facilities, mobile facilities, or customer-defined facilities. The laboratory shall monitor, control, and record environmental conditions. There shall be effective separation between neighboring areas in which there are incompatible activities. Measures shall be taken to prevent cross-contamination. Access to and use of areas affecting the quality of the tests shall be controlled. The laboratory shall determine the extent of control based on its particular circumstances. Measures shall be taken to ensure good housekeeping in the laboratory. Special procedures shall be prepared when necessary. The Codex guidelines for the design and food testing laboratories are applicable, and can be other regulations and standards that may be consulted. there are different types or formats of methods used by laboratories. The laboratory shall have instructions on the use and operating of relevant equipment and on the handling and preparation of items for testing, or both, where the absence of such instructions could jeopardize the results of the test. So laboratories may use for test methods standard methods or in-house methods. Standard method, if international, regional, or national standards or other recognized specifications are written in a way that they can be used, the laboratory do not need to rewrite as an internal procedure. When the laboratory use in-house methods, like methods based on standards, this type of methods make up a major part of many laboratories' scopes. Since it avoids the commitment of being pinned to fine print of the standard specification, and it is possible to maintain the credibility provided by the standard specification. So it's an adaptation of the standard. And then we have non-standard methods. That is the method which are the laboratory's own method. This must be subject to high level of validation. ILAC and regional bodies such APLAC or EA also provide guidance documents for laboratory community. So these are almost standard documents, where regulatory authorities prescribe methods to be used for testing under their regulations. Laboratories should ensure that the requisite method is used. The Codex, for instance, is recommended as an acceptable reference for sources of test methods when they are not specified by regulation or by the customer. But all methods need validation. There are different types of validation that can be adopted, such as calibration, using reference standards or reference materials, comparison of results achieved with other methods, interlaboratory comparisons, systematic assessment of the factors influencing the result, and the assessment of the uncertainty of the results based on scientific understanding of the theoretical principles. Validation is the confirmation and the provision of objective evidence that the particular requirements for a specific intended are fulfilled. The validation of methods must be performed every time that new equipment is introduced to the laboratory. The laboratory is attempting a new standard method for the first time. Non-standard methods are developed by the laboratory, and a standard method used outside its normal parameters. And then testing laboratories shall have and shall apply procedures for estimating uncertainty of measurement. The uncertainty can be defined as the amount of possible inaccuracy of a test, and it is often a statistical estimate of this range. Uncertainty components are a combination of many factors that may include, but not limited to, reference standards, reference materials, equipment used, environmental conditions, properties and condition of the item being tested, calibration, or even the operator. Also, laboratories must have procedures for data control, which involves validation of software. Software can be commercial, off-the-shelf software, or developed by the laboratory. So calculations and data transfers shall be subject to appropriate checks in a systematic manner. Systematic verification of calculations and data transfers must always be performed regardless of how they are performed, with or without any type of resources. So commercial software in general used within the designed application may be considered to be sufficiently validated. However, any software configuration or modification by the laboratory should be validated. The computer software developed by the user or the lab shall be documented in sufficient detail and suitable validated as being adequate for use. And then the validation, the control data includes the data protection. And then a procedure of data protection shall include the integrity and confidentiality of data entry collection, data storage, data transmission, and data processing. Equipment. All equipment shall be checked or calibrated before being placed into service. Equipment shall be operated by authorized person, and each item of equipment shall be identified. Records of on equipment that shall be maintained are the identity, the manufacturer's name, the type identification, and serial number. The checks that equipment complies with specification, the assessment of the capability of the equipment to work, the current location where appropriate, the manufacturer's instructions, the dates, results, and copies of reports and certificates of all calibrations, and the due date of next calibration, maintenance plan where appropriate, and maintenance carried out to date, any damage, malfunction, modification, or repair to the equipment. The laboratory also shall have procedures for safe handling, transport, and use of measuring equipment. Any equipment that is not suitable for use shall be marked and removed from service, and all equipment shall have an indication of its calibration status. There are many methods that are appropriate and include, but are not limited to, label that indicates that it's calibrated, date of next calibration, and person responsible for calibration. You can use a color code, and for those items that cannot be directly marked, such as weight, thickness, gauges, the status can be placed on the storage container. The idea of this marking is to ensure that the equipment is not used past its calibration date, or any method that will ensure this is appropriate. Just a note that report results of tests performed by an equipment out of date of calibration is a non-conforming work. The laboratory must establish a calibration program. So just to define traceability, it can be defined by the property of a measurement result whereby the result can be related to reference through a document unbroken chain of calibrations, each contributing to the measurement uncertainty. So this means that all equipment is used for tests or for subsidiary measurements having a significant effect on the validity of the result of test must be calibrated before being put in service. So, calibration program includes equipment that have a significant influence on the results of the tests, and equipment that calibration is required by standards or specifications. This calibration must be performed by accredited calibration laboratories. Sampling, the laboratory shall have a sampling plan and procedures for sampling when it carries out sampling of substances, materials, or products for subsequent testing or calibration. This clause applies only to laboratories whose work involves the extraction of samples as part of the testing program. Laboratory must have and keep procedures for the transportation, receipt, handling, protection, storage, retention, and or disposal of test, calibration items. Identification of items, records of abnormalities, and preservation of samples. It is critical that food testing laboratories preserve sample integrity and avoid contamination and deterioration of the samples. Food is frequently perishable and should be stored in a manner to prevent deterioration. This can be with refrigerated for short-term storage and frozen for long-term storage. Some parameters deteriorate, and so the analysis for those should be done upon the receipt. And then there are some methods of assuring the quality of test results, such as the use of certified reference materials, participation in inter-laboratory comparison, replicate tests or calibrations, retesting or recalibration, correlation of results. Not all methods will apply to all tests, and in some instances it will not be possible at all to use any of these techniques for certain types of tests. Quality control data shall be analyzed, and where they are found to be outside predefined criteria, planned action shall be taken to correct the problem and to prevent incorrect results from being reported. And now we pass to the reporting of the results. And the results of each test, calibration or series of tests or calibrations carried out by the laboratory shall be reported accurately, clearly, unambiguously, and objectively. Test report calibration certificate shall include a title, the name and address of the laboratory and the location where the tests calibration were carried out. If different from the address of the laboratory, the unique identification of the test report or calibration certificate, the name and address of the customer, identification of the method used, a description of the condition of and an unambiguous identification of the items tested or calibrated. The date of receipt of the test or calibration items, reference to sampling plan and procedures used by laboratory or other bodies, the test or calibration results with the units of measurement, the name, function and signature or equivalent identification of persons authorizing the test report or calibration certificate, and very relevant, a statement to the effect that the results relate only to the items tested or calibrated. There are other specific requirements for reports with interpretation of results and for reports containing sample results, and that are included in the standard. As I said, the ISO 17025 are being revised and at this moment, and it's expected to be published in October 2017. The format of the new standard will be significantly changed to be more close to the new ISO formatting guidelines. It is expected that the new version will be aligned to ISO 9001 of 2015 principles and resources and process. If you see the content in requirement 8, for management requirements, it will be possible to choose if we want to the compliance with these requirements, with the 17,025 included management requirements, or if we can meet the ISO 9001 management requirements, and then we will expect for publishing of the standard, and we will see the other changes that it may include. And it's all. I hope that I have helped helps you to understand a little of what is accreditation, what is an accreditation system, and management, quality management system. Thank you.
Thank you, Nuno, for this very, very comprehensive overview about the standard requirements. As I can see till now, we have no questions from the audience. This may also be due to the involuntary extension. I'm very sorry for the technical problems we had to face this time in this webinar. Thank you, Nuno, for successful troubleshooting. I hope you could enjoy the webinar nonetheless. And I again apologize for the lengthening of our webinar today. If there are any questions, so you're still invited to post them to me. I'm still online and many of you are still too. Nuno is also online and ready to ask your question. I have here some acknowledgement from Mihira Kamela. She said it's very interesting. Thank you, Nuno.
Yes, thank you.
Well, as it seems, it was very comprehensive and a lot of information packed in your lecture, so no questions open as it seems. So I may thank the audience and I may thank our today's speaker for the webinar. Thank you for your patience and have a good day. We will meet maybe sometime again for a Foodstar webinar. Goodbye and good afternoon.
Okay, good afternoon.